This lecture will cover probability and statistics. Over the course of this module, you will learn how to define statistical terms that you should have been introduced to during your undergraduate statistics course. In addition, you'll calculate and use sample moments to analyze data. We will define what sample moments are, which are your mean, variance, skew, for example. Next, we will differentiate the difference between mass and continuous functions. Then we will start the application process in hydrology and learn about other mass and continuous functions that can be used. So let's talk about probability and statistics terms. Before you can ever get started, we need to be able to collect data. We need to understand the difference between a population and a sample. So when you think of a population, it's composed of all events. So imagine we're looking at Cal Poly Pomona, our institution. The population would be the 24,000 students that are studying here. While we might take a smaller random collection of the subset of that population. Maybe at lunchtime, we'll go to the cafeteria and take the 300 people that are eating at that time. No, samples are used to make inferences about the population. They are not composed of the entire population. Taking a good sample is essential when you're evaluating statistical concepts or trying to make inferences about a population. Next, precision and accuracy. When we're taking data, there's two thoughts. There's precision, which is the degree to which the measurements or calculations show the same or similar results. Meaning, you can have precision, but it's not at the target or the accuracy. While accuracy is the degree of closeness the measurements or calculations are to the value you're interested in. The best example is to think of a bullseye. You're playing darts. The goal to play darts is to hit the bullseye. If you can consistently hit the same area, you are precise, as shown in the top two schematics. However, you're precise and inaccurate when your data is not hitting the target. Maybe your viewport is off and you're not able to hit the yellow target. You're considered imprecise when your data is all over the place. However, you're accurate when on average you're hitting your target. And so that's why in the bottom left corner you're seeing accurate but imprecise. And when your data is neither precise nor accurate, your data does not hit the target, your data is not close to each other. You have systematic error and error in reproducibility. So probability is important. It's used to describe the likelihood of an event. So let's say this. What's the probability that I will have a jacket on today? You never know. Is it cold outside? Is it hot outside? Do I like to wear a jacket and I always wear a jacket? So you never know. So it's important to understand that we need to use the past events to predict what will happen. So we'll look at me, for example, over the past 30 days or past 365 days to determine this. If it's perfectly one, meaning every single day I always wore a jacket, then you'll have one. But if I never wear a jacket, then the certainty of failure occurs and the probability will be 0. So the way you write this mathematically is what is the probability that x will equal x naught? It's equal to n divided by the total number of samples. So x naught is our desired value, x is our sample over the next 365 days, what's Dr. Fairbank wearing? And x naught is our desired value, positives. So how many positives of this happen? So what is that value? Yes, she's wearing a jacket. It's either jacket or no jacket in this case. So how many positives occur? Let's say out of the 365 days, 300 of those days were positive. That would then be able to help you with the probability. So during class, We'll do other examples of probability, but let's look at this. I've got a dice, and I'm rolling it. What's the probability I'll get a 2? Well, there's 6 sides to a dice, so my big N is 6. The number 2 only appears once, so the probability of occurrence is 1 over 6. During lecture, we'll do this example of a temporary construction berm, and we'll evaluate what that probability